name is Daniel, and I'm a respiratory therapist. I manage a couple of teams at USC at the Keck Medical Center, and so the pandemic was very exciting for me. On March 16th, at the beginning of 2020, that is when we had our, I believe, formal shutdown of all non-essential businesses. And so my wife's office in Pasadena closed, and we had a talk about what to do. And so we decided that she, who at the time was pregnant with my son, and I had a 3.5, 4-ish-year-old daughter. Oh, you'll need those. Decided to move to her parents' house in Camarillo, and I decided to move into the hospital. So this is just a recent photo of us. Very interesting couple of months after that. So, of course, you all know, the significant surge of infections and the huge demand on hospitals across the nation. There was a big delay between how bad the volume of patients entering the hospital was from the East Coast to the West Coast. There was started in Washington and New York, and didn't get to LA really till more like the summertime. Closer to the beginning of July is when we were really very burdened with COVID patients. So NIOSH and CDC, who work very closely together, decided that there was definitely going to be a really big problem and a shortage with a lot of things, but one of the main things that was of concern was protective equipment for the people that were going to be taking care of the patients. So they pretty much overnighted a very, very long list of masks and already registered respirators within the system that were international, and decided that it was worth just kind of automatically making a bigger list so that we could have access to devices that were approved that would make sense, because they wanted to avoid a big kind of crunch panic for the people in charge of supply chain at all the health systems, which kind of ended up happening anyway, but it was an effort to try and be prepared for that. So when that happened, many respirators entered the system for healthcare that probably had not ever been used there before. We really didn't use N95, even for my team being the respiratory therapist or dealing with maybe the patients who have an airborne disease most frequently, really that often. So as an example, the academic medical center would probably use PAPRs or N95s maybe 10 times a year, so very infrequently. And now we were going to use with all these new devices, and so whenever a new device enters the health system, the regulations from the government through OSHA say you have to fit test the people to make sure that they fit them properly before you allow them to use it. This is one of the regulations that was waived when there were no masks available and there was no real feasible operational strategy to deal with fit testing prior to implementing. So it was waived for a short period of time in 2020, but the normal procedure would be to fit test anyone who would need to wear a mask. So I'm sure you're thinking oh, this makes a lot of sense. You don't just give somebody something that's supposed to protect them without making sure that it does, especially if you could die when you're doing your work. All right, so I have a very short regulatory joke because I have a graduate regulatory education, which means my wife thinks I am very boring. So the funniest part about this slide is that it is from 2001, and now that number is 1.8 billion. Thank you for enduring that. So my health system is about 5 hospitals, and we have at the main hospital 84 ICU beds. We have 5,000-ish employees. And at this kind of crunch time where all these new respirators were coming to the health system, we had to find ways, creative ways, to fit test people kind of rapidly, over and over and over again. And so I kind of volunteered to help out because the employee health team was so small. In fact, they were less than 10 people when the pandemic started, and by July, they were up to like 40, 50-ish. So there's a huge burden just to try and make sure we were using safe equipment with like our nurses, doctors, respiratory therapists. We also really limited the number of people that could take care of COVID patients. So about 2,000 RNs are involved, 160 of my staff, and overall, though, with all the physicians, trainees, students, it's about 5,000. And probably the absolute worst part of our burden was that for PAPRs, which are recommended for any aerosolizing procedure, which means anything in respiratory therapy, basically. Any aerosolizing procedure, you have to use a PAPR. That is the recommendation because of the risk of exposure in that environment it's a lot higher. So if someone is having a procedure in the airway and we're jetting air or medicine or cutting or using a bovine surgery or really anything, it aerosolizes particles at a high volume, and so you have a much higher risk of getting sick. So at the beginning, we had 9 for the entire campus, which is really not at all enough to sort of manage procedures in the ICUs, and definitely not in the OR. And so we had to come up with a lot of creative solutions. And one of the things that we did was we made a cart that had 4 PAPRs on it, and we had just a team of people that would run it all day, every day, everywhere, all the time. It would just kind of run around procedure to procedure. And then we identified particular providers who were going to be in charge of intubation, since it's a really highly aerosolizing procedure and a high risk to get sick. That person would wear it all day and would try to do all of the intubations in the OR, which had to change like all of our workflow and a lot of different things. Okay, talking a little bit about the problem with fit testing. So as Daryl alluded to earlier today, the most common method used for fit testing employees in hospitals and most places, with the exception, of course, of BSL 3 level and higher labs, they use qualitative fit testing. So we're using the joke from earlier. If the test is looking at whether or not you can taste particles, and we have literally millions of people infected with a disease that causes you to lose smell and taste, as like one of the more common symptoms, it's kind of a no-brainer that this is going to be a problem. So I was really concerned about my team and about the people that I was working with, so much so that I went and stole a bunch of equipment from the university, which was fun, and we raided the BSL 3 lab that was shut down for a little while and took a bunch of their stuff. And we found a port account in the Employee Health Center on the main campus, brought it to the hospital, and we kind of like started up our little corner of investigating student health. Yeah, sorry about that. Yes, sir. A respirator is a passive mask. So NIOSH has some interesting language. They refer to them as filter media, filters, respirators, N95 product. But respirator, in the sense of what we're talking about it in this talk today, we're talking about the passive N95 masks. Yeah. Please interrupt me, by the way. Go ahead. They do. Correct. So you would think that, but actually there's a lot of data out there and papers on the problems with qualitative fit. One of them being that people just don't take it that seriously, and they don't really understand it half of the time. Most of them, when queried after an exercise, think that they were supposed to smell something. So there's actually a lot of just a gap in general with people taking it seriously. There's also a huge gap in its efficacy. I think it's pretty well documented that it's only about 60% effective. So, you know, that's not very great when you're thinking about the pandemic. So, but yeah, thank you for bringing that up. It definitely has more than one problem. In our observation at the beginning, when we decided to start looking into it ourselves, we teamed up with a few people at different universities. between Caltech, USC, and UCLA, and we made a very long list of the masks that we thought would work well and then those that would not, and we found 173 different approved respirators that didn't seem to work so great. So, what are we supposed to do about this? Yes, sir. It's a really good distinction, yes. So I am talking about it from the lens of the filter media all working perfectly fine. And by working perfectly fine, I mean the filter material itself would capture 100% of 40 to 70 nanometer particles all of the time. And so the filter is fine. And the problem is that everyone's face is really kind of like a fingerprint, and trying to have sort of these, simple standard shapes really don't necessarily fit as wide of face shape variants that there are just out there in the world. And organizations like NIOSH actually have regional mannequin face types, and so they have 7 regions of the world with like an average face shape, and then 5 sizes of those average face shapes across the 7 regions. So it's kind of they do their best to try and make it easy. So July 7th, we received word that we were going to be getting multiple pallets, like something like 20 million units of this particular mask from Makerite called the N95. And so we had established by this time sort of an internal protocol of using quantitative fit testing as a gatekeeper for implementing new products. And we found that we couldn't make it work really for anyone, meaning it did not fit anyone's face that we put it on. And if you're familiar with this particular mask, it would be like if you sawed a globe in half, and it was almost like a perfect circle cut in half with tabs on it. So this shape was really rigid and really not really forming well to the face at all, and just always on almost every person would have huge, huge open gaps, which for the people that are going to go into the ICU or into the clinical environment was like obviously not a good thing. My first assumption was that this was a manufacturing problem, or we had received counterfeit product, or we had some problem that I didn't have a good way to measure. And so looking at how we would send the message out to the proper authorities or get help from the right people, really just landed on using MedWatch as a med device reporting system as really the go-to, since that's what we do most often in the hospital. But in reality, that probably was the slowest approach that we could have taken to the problem. But that's what we knew how to do. Within a week, though, I was able to catch up with the local regulatory board in California, which was called Cal-OSHA, and we made actually this slide deck, but shorter, to explain our situation to them. And at that time, they told Mark and I, yes, we know, thank you for working on this. Could you please call our friend? And this was the deputy chief at NIOSH. So we said, sure, absolutely. About a month later, we were able to meet with Colleen and explain our situation to her and her team. And she also empathized with this situation as not new news, but something that they had been working on since 2008. And unfortunately, back then, they had lost a lawsuit with the lobbyist around changing the rules at NIOSH to implement new requirements for manufacturers, because it was going to be very expensive for the manufacturers, and there was really, at the time, probably a good argument that there wasn't really a good burden that made sense that they needed to spend all this extra money and make these big changes. But, hindsight's 20/20. So, there were some questions earlier about the regulatory agencies, so I made this slide while Daryl was talking. So the CDC, they make a lot of recommendations to the public, and they work alongside, industry and a lot of professional organizations to kind of get information out. NIOSH actually tests and validates that a industry or a sponsor who's submitting a product not only is meeting all of the GMP and the other sort of industry requirements, but they are actually sending to the agency what they're going to be making and sending to the public, and so they have procedures for validating. Unfortunately, still to this day, there actually is not a strict validation for fit. It is a sort of gray area of you assert that you have implemented one of the protocols, either qualitative or quantitative. They have a procedure for doing those protocols that you perform and then you submit, but NIOSH does not retest and validate that your fit exercise is, true to real life. There's no validation testing for that. Okay, FDA, they do a lot of things, but essentially they're really built on just two words, and that is misbranded or adulterated. Everything, from the FD&C Act is based on those two words, so they do that across a broad swath of things, from med devices to drugs to biologics to food and cosmetics and other things. Okay, so the masks don't fit, so what are we going to do? We're just not going to use them, or do our best to not use them. And we, through this internal process of testing and eliminating options, really narrowed down the sort of masks that we were looking to buy, which was really stressful because at that time we had already purchased some masks that were not going to work, and so we had to figure out what to do with those and how to get them, maybe get our money back for them or figure something out or sell them, or, this comes to like an ethical problem, because if you're selling something you decided not to use, you're like, ugh. So we, after about 18 months, we were able to return them to the manufacturer. I think one of the more depressing moments when reliving that timeline is we were sure that this was a very large problem and that we needed to try and help as many people as possible with this problem, but it was a huge operational lift and a really big believe it issue as well. And so while we did our best to try and tell our friends, and I mean friends, I'm talking about other AMCs and systems, most of them it wasn't feasible to sort of implement the protocol that we had decided to implement. We're sort of kind of living in a bubble as well, because my main hospital does not have an emergency room, so it can't really get flooded with COVID patients like a normal, let's say, county hospital. If we have a county hospital, which was a different situation. So yeah, at the end of August, which is sort of the tip down on the first peak here in LA, our infection rate for the providers and staff that were working with COVID patients was only 0.27%, which is insanely low. That's crazy low. That's lower than probably everywhere in the entire country. And there's a lot of places that are not measuring it, so it would be hard to prove that. But it's very low for those we compared ourselves to locally. And places like Cedars and UCLA and UCSD or UCSF or Stanford or other very large systems were all above 5, and some of them closer to 8. So many times the infection rate that we were seeing, and at that time we felt like, now we need to make a bigger deal of this. Yes, sir.
So, sorry to interrupt.
No, please keep doing that.
I want to return to the first bullet and just make sure I understand. So, NIOSH today does not have a test for fitting the human face. So
that is accurate. Well, that is not accurate. They do not have a requirement where it is written into the rule that they must validate the fit procedure that is submitted to them. But they do have the ability to test it with ASTM now.
okay, but this situation has persisted since I think you said 2008.
Correct.
What's that?
Yes.
Okay, so it's been a long time.
Correct.
There has been no market pressure, or no one noticed, or no one cared to address this problem previously, or is this the lobbyist issue?
It is a lobbyist issue. So it's a money issue. When you want to change rules in the government, and it creates a huge financial burden for manufacturers who need approval from the government to sell their product, you have to make sure you have a really good reason for that, because they will throw a lot of money at making sure that either...
In a nutshell, someone noticed it was a health problem, asked the government to require these tests, and the lobbyists sued the government to prevent the government from requiring these tests.
That is basically accurate. Yeah, and that would be around the Ebola timeline. Yeah. And I don't want to say that it's so direct like that. It's a little bit different, of course. concerns were raised by those at NIOSH about their rules lacking a strict requirement for fit. And so they wanted to, come to consensus with industry around what would make sense and how they could work together to get to a place where there is a strict requirement. And they thought they had that. And so they submitted that, went to the Federal Register, went to public comment, and then it got sued and lost and never was implemented because they lost in court for the game against the cost was worth the burden. Although now, we have the hindsight is 2020 thing. So limited options. We were looking at, as I said, 173 no longer options for us, and had to try and stick to the very few products that we knew fit best in our workplace. That's probably the most accurate way to say that. And so we were looking at a short list of about 5 different respirators made by 3M and Honeywell and Halyard. And the 3M respirator that we chose to buy in bulk was actually very contentious at the time because it has a valve on it. But we decided that it was worth prioritizing the safety of the staff over the off chance that we had people who were infectious, who didn't know, and were potentially passing, contagious particles into the environment where everyone already had COVID. So it didn't make too much sense to be worried about it, and so we decided it's better, this fits better, it's safer for our people, let's do that. And we just kept it in the areas where, all the patients already have COVID. And we didn't use them, let's say, in the OR where, we already have a concern around, people wear surgical masks in the OR during surgery because we don't want them spitting into people. So you wouldn't want a mask that had a valve on it because you could, accidentally get, oral secretions into, maybe a surgical site. All right. Math to the rescue. We now need to figure out, because we failed at, changing the rules, because that's not an overnighter, and apparently there's a long history of problems there. We needed to figure something out. We needed to do something. We knew too many people who are having problems, who don't have access to anything else. And so we're like, okay, how can we make use of what they do have access to? And so we decided to collect our, group of hoodlums who are good at the maths and the beep boops. And that would be some of the folks here today and some of the folks who are maybe online but not here today. I needed major beep boop help. That is not my thing. Available to us were some very smart people that were working on solutions for other things like oral implants for dental implants. And there's a company called Bellis 3D who had come out with an app that would provide a file that would create a fingerprint-like frame for your face that would increase sort of like finger pressure around a surgical mask. And the idea behind their product was to reduce community spread by making regular surgical masks fit on your face better so that like the leakage wasn't as big of a problem. And so we immediately thought about like reverse engineering this idea and decided to start, we contacted them, we spoke to them a few times, we got some software set up, and I got one of their little cameras with the little, beep boop thingy on it that like, checks stuff on your face and creates the file for you. And so the problem with that, though, is that since everyone's face, as we talked about earlier, is kind of like a fingerprint, it's really an operational nightmare. I mean, we have 5,000 employees. That's like 5,000 faces that have to be scanned, and then there needs to be some bank of printed frames that would like be available when they broke it or whatever. It wasn't a really safe idea or an efficient idea, but it did work decently, with the exception that their frame, since it was trying to lock air in, actually had a major leak problem down below, and so it wasn't perfect anyway. So we kind of needed to start from scratch with something that was going to work across as many faces as possible, as quickly as possible. So here are the team members involved from the beginning. This is sort of the same group of people working on a few other projects at the same time. And this is a rendering of one of those frames from the early days that we ended up using for the paper that we published this in. And what we did was we took the NIOSH head forms and made estimates for what would be sort of the closest to the middle across a couple of the head forms, and to come up with a shape that we thought was a good starting place to start testing. And so this is an image of what that looked like. Oh no, there was a delay click. Sorry about that. Here's a couple of images of the early frame. One of them on the far left is just the bellis frame on my face. Those in the middle are our first version of the new frame that we created. And it might be hard to tell from the images, but if you look in the lower section on my face there, you'll see it's kind of like a lot more hard angle, pointed, like sharper angles, whereas the one we created ended up being much more rounded and almost flat and longer along the sides, which would go further along the face and up the cheek. The frame that we ended up using for the testing is there on the right, and that's on one of the Honeywell masks, the 300C or something like that, and the DE2322 BYD Care mask, which was one of the largest volume masks distributed out of the Port of Los Angeles to healthcare workers. This is some of the data from our paper around what we were seeing in the days when we knew we needed to start working on a plan to fix the problem. And so we have the 1860, which is the surgical 3M mask. That mask fits incredibly well. It already has multiple sizes, and it's okay to use in the surgical environment, so that's why we already were using it in the hospital. That one, turns out, fits really great. Across all of the quantitative testing protocols, it was really awesome, like best scoring. And then you'll see there in the closer to the middle, you have the 8511. That's another 3M product. That's the one with the valve. That one also averaged passing scores across all the 8 exercises from the OSHA requirement, the protocol for fit testing. And so you see why we chose that as the bulk item to stock the health system with. In the middle, the 9500, that's the one that I received in July. Yes, sir.
What are the
So these numbers represent a aggregate score from the software of the TSI port account system, and it is called a fit factor. It's sort of a moving target based on particle leak. So higher is better, yes. And above 100 is passing.
It's between 0 and 200.
Yeah, it's actually between 0 and 5,000, but 200 plus is where, when you put it in N95 companion mode, what it does is it changes the voltage on the optical particle sensors so that it focuses on counting only 40 to 70 nanometer particles. And when it does that, it's assuming that if the mask fits you, that there will be 0 particles of that size sampled from inside the mask. So the way that the system works, it's got 2 sampling lines. One of them is connected to the mask via a port that you create. You punch a hole. The other is sampling ambient air. You saturate the room with a minimum of 200 particles per cubic centimeter. And once you're at that saturation, you can then proceed with the testing. And what it wants to see is that none of those 200 or so particles per cubic centimeter enter the mask at all throughout the testing protocol. Because if they do, that means 40 to 70 size nanometer particles somehow got through the seal on your face. Does that make sense? So the DC300, which is the Honeywell mask, it did work a little bit better, but this is the mask that you might remember was made in Arizona at that factory they stood up for COVID. And like the president went there and they were like talking about it. But that mask shipped with no foam seal and no wire, which really kind of doesn't make a lot of sense, because if you're going to use that in a hospital, every time you move, it's going to leak. So it really struggled during the exercises where anyone had to do anything. And if you know something about the fit protocol, you know, you have to turn your head side to side, you have to move your head up and down, you have to talk, you have to bend over. And anytime you did any of that, it would automatically start to fail, even for the rare face that it did fit on. And it really seemed like it was made for like a Viking human that was like 7 feet tall and large, because the mask really only fit really large people. Um, and then on the last column there, where you can see everything is averaging into the green again, that is the same mask, that BYD Care mask, the pointed one, that a lot of people still wear and are mimicked after the KN95. That is our frame on that style mask. So you see it went from failing miserably, or about half of the expected protection, to well over the passing range. So we thought, yes, excellent, great, overnighter. Yes, we've just solved all the healthcare workers getting sick from the pandemic. But that's not actually what happened. All right. Here's just some other illustrations of, in this table, you know, the passing line is right there in the middle, 100. You were asking about what the numbers meant earlier. So the three columns below are, you know, labeled probably very small, difficult to read, but the first one is the 9500. That's the make-right mask that I received July 7. The DC300 is the red one, and then the DE2322 without the frame is the purple one. So the three above, the yellow, the light purple, and the orange, are the two 3M products we talked about, and then the folding style N95 mask with our frame on it at the end in orange. So it was just about performing as like the normal masks were performing. So who thinks we were able to just give it to everyone and use it in the hospital? What might be wrong with that? There are some rules about emergency status. So if you start to use off-label or unapproved products in your health system, you have to declare emergency status, meaning you cannot do anything like normal. You now have to constrain your entire system to operate within emergency only, meaning you can't do most surgeries, you can't see most patients, you can't really do anything normal, you can't even see cancer patients. There's a whole lot of things that you are now do because they don't want you doing things with equipment that isn't validated, and that makes perfect sense. But from a feasibility, real-life standpoint, during the pandemic, it didn't make much sense. So if we were to implement them and just shoot them across the nation for people to use with those folding masks, that would have basically put any hospital that used them out of business because they wouldn't have been able to pay their employees because they wouldn't have been able to see any patients. And then it kind of doesn't make any sense. You kind of have to stay open and see patients. Okay, so we met with Kalasha again. We shared the information. We let them know that we felt like we had a solution, and we wanted to know what the quickest regulatory pathway to approval would be. They quickly said, we don't do that, and please call NIOSH. So we did that. We called our friends we'd been talking to for about 5 or 6 months at that point, meeting with them monthly to kind of go over how things were going. And we shared with them, hey, we have a solution for this one style product in this category where there are tens of millions of them everywhere. All police, all fire, all EMS services in California, most of the county hospitals, the VA, everywhere is using this product because it was bought in the tens of millions by the government. And so they let us know that because it sort of meets the definition for respirator accessory, it can't be used with any mask that it's not submitted with. So what we would have needed to do, and what we tried to do when we called the CEO of BYD, was to request that they resubmit an amendment to their application with NIOSH, which was emergency authorized without any data, to include an optional accessory, which is basically like the most benign way to say, hey, your thingy doesn't work. We have a thingy that helps it work better. Please don't say that, but allow us to add it as an option, and then people will have thingies that work better. And so that ended up not happening, unfortunately. But, you know, we tried. And NIOSH really tried to help us out to partner us with manufacturers who might be open to that, especially those who were working on creating local manufacturing for the future, because that's still ongoing. A lot of companies are trying to create, you know, sort of a within the continent supply chain, and that makes a lot of sense. So they were partnering us up with those people, and we still work with manufacturers who are trying to do that and stand them up. We ended up publishing it, so some people may have read that, and we're still working on this. And the good news is that in November of 2021, NIOSH resubmitted their proposal for the rule change, which includes this strict requirement for quantitative fit. There, of course, will be, some looming battle in court at some point. But for now, in terms of public comment and otherwise public engagement, there's a lot of support for making a change because it makes a lot more sense today, probably than it did in 2008 when it failed. They also released new guidance, and in their new guidance documents, they reference the proposed rule, and they talk about how manufacturers should prepare for future requirements, including strict quantitative fit testing. And that is the end of my presentation. Are there any questions?
I will add one addendum to Daniel's presentation because he and I have been trying to talk about this, and I failed in this one. Part of the reason why I think this talk belongs at scale is the Fitra frame that he was describing is available. The STLs for it, if you want step files, we'll get you the step files. If you want to print your own or if you want to start iterating on it and coming up with your own versions of this, they are available on github.com/Tetra Bio Distributed. And if you need me to write that down for you or whatever, I can text it or give it to you. So, and I would
email me, and then I'll forward it to you, and you can forward it to them.
That'll also work. We do also have the data that was used in the fit testing stuff, but we are not allowed to give that out because there's people's names in it. So we will not. We have the data, but we cannot open source that. So I hope you will bear with us on that one because there are laws that say we cannot. So having said that, sir.
Yes, sir.
I got some more questions about qualitative versus quantitative fit test.
Sure.
I got a qualitative fit test kit.
Okay.
Because you can buy them, right, for small businesses.
Amazon. Yep. 3M
the 3M
kit. Yep.
FT10, I think, is what I got, right? And the 3M one's way better. It's got a way better hood.
Sure does.
I had an Allegro one before that, and it's just a bag you put over your head.
The 3M1's the one we use in the hospital.
Yeah. So one of the, and it's a pretty simple procedure, so I'm trying to get all my friends to do that. I was trying to get a professional to come by work. But, and I've read about the quantitative fit test, and I've read this better. But, I mean, it's a lot more expensive, right? I mean, the fit test kit I got is a couple $100, right? It's pretty cheap.
Right.
The port accounts are like 10 grand.
Yeah, they're more. The port accounts are, depending on how many you're buying, of course, they're about $14,000 to $15,000.
Yeah.
With like a PM package and service and all of that.
Ah, okay. Well, I mean, somebody was offering to sell me one for 10 grand, but
Yeah, you can probably
without the support.
You can probably eBay the older ones for maybe $1,000, actually.
Oh, if you want the ones that aren't calibrated, those are way less than $1,000.
You can pay to have them calibrated, and you can mail it.
Ones?
Yeah, you can mail it to
okay.
Minnesota, where they do all of the calibrations for TSI globally.
Oh, really?
Yeah. In fact, I recently was working with one of the TSI engineers to calibrate a 8130A, which is the device for filter media testing, for penetration testing and other testing. And they actually have really stood up a lot more in terms of service for the legacy products to be calibrated and make sure they work since the beginning of the pandemic.
Nice. Yeah. One thing I'm working on, I'm trying to get a group of friends together to get some professionals out to do this, just because it's like, I'm a guy, I have the kit, I read the instructions, which actually I think is all that that OSHA requires. Not 100% sure, but I think so.
Yeah, so it's the OSHA 29 CFR 29 1910.134. That section is got both fit test protocols in it, and it outlines very in-depth each step. And you can probably get it on like a .gov website.
Okay.
But you could also go to NIOSH's website and download their most recent guidance, which is from June 29th. And it also has those sections in there. They have SAPs for everything.
Okay. Yeah, I was just following the instructions from the kit because I figured 3M probably wouldn't steer me wrong.
Definitely. The kit comes with proper instructions, yeah.
All right, cool.
Yeah.
But what you're saying is that there's a big jump up to the quantitative, right? You're saying that's way better for...
There's papers that say efficacy is as wide as a gap as 40%. so that you could have as much as a 40% error rate using qualitative. Because taste is a difficult difficult metric.
Yeah.
Yeah. Even with the whole idea of it being very sweet or very bitter.
Yeah, yeah. And they are, oh boy.
Yes, they are. But it is still tough, especially when the procedure starts with seeing how much of a dose makes sense for the person you're about to test.
Yeah.
They have now just tasted it.
Yeah.
And now they're so sure what it tastes like. And you'll notice that after that point, they're no longer sure whether or not they're tasting it.
Yeah.
And there's this sort of subjective game of, I don't think I taste it. I'm not sure.
Yeah.
Yeah.
Yeah, a bunch of my friends, we did it like 2 or 3 times before we were like, oh yeah, okay.
Yeah.
But
okay.
Yeah, yeah. Sorry.
Anybody else? Any other questions?
So one of the other problems with the qualitative the qualitative taste test is that it actually doesn't challenge whether or not the mask material itself is N95. So one of the things that we discovered while we were doing this testing is that qualitative test just tests for leak. So if the mask is leaking, what happens if you're wearing a counterfeit mask? You wouldn't know with just the qualitative test. With the quantitative test,
we found more than 30 times we had counterfeit masks sold to us by big distributors. McKesson, Medline,
Well, keep in mind this was during the
not their
shortage.
fault.
Yeah.
I mean they're going through their normal checks and balances. They're just really good counterfeit products.
But just keep in mind that test doesn't test for the mask itself, and that's actually a very important distinction because we found online there was a lot of misinformation about that.
Big time.
Yeah, there was a huge amount of misinformation about that.
The
people were
ports
suggesting
have a receiving validation where they have a quick tester, and the Port of Los Angeles as an example. So they would open a random box and then put a mask on it and then run a quick penetration test, and so then they would have some data. That's usually like the top one. So if the top box was normal and then the rest are not, it's kind of not impossible to sort of fool. Yes, ma'am.
Yeah, so perhaps I missed it in between, but from what you said, there seems to be like 2 extremes. There's one kind of mask that fits a 7.5-foot tall Viking, and then there's a set of masks that fit just sort of like, a rain. And then there's like the perfect fit that is like literally individualized to an individual's face. What is a good in between that still fits a range of faces? Because frankly, looking like I do, when I hear, well, we have like regional fits that sort of fit the average face for that region, I'm like, well, that's never going to be me.
Right. Yeah, so that's why OSHA has the requirements that they have, that you, at least in the working environment, which is the only environment they have control over, that you have to test that it is a good fit for your employee. So that's why there's so many, because the many options really do cover a lot of different faces, because they are kind of, quite a bit of them are very different. So together, if you had a lot of them and you could select the best one for each employee, that's really how the system is supposed to work. That's sort of not totally reasonable if you have to test, 173 of them. Like we did something like 240 different respirators through our little bank of testing. And, no system anywhere that I know of is going to have that many different products. They're going to have maybe 3. So what ends up happening in the hospital where you're concerned about, them definitely getting sick, you would either not have them work in that environment or have them wear a higher level of protection, like a PAPR or another device, or an elastomeric mask. Or, you find a mask that fits them.
Yes, my question is that, like 3M, they have small, medium, and large.
They do. They work with, actually 3M works with the same engineer that designed the different sizes for tampons, because from like a biological calculation experience, there's not that many different devices where you had to use math to figure out how many different sizes made sense for a particular, fit. And so what they did is they have 3 here. In other parts of the world they have 5, and in other parts of the world they have 2. So they appropriate the like amount that makes sense for where they are. I don't know if they're all still like that, but most of them are 3. But it isn't just the one, like, fits one. They have like tiers, and
Yeah.
they follow the regional map as well.
Because NIOSH has small, medium, large, extra wide large, and extra narrow large.
Right.
So
Yeah, which is essentially tall, the
Yeah.
extra narrow large. Right. Well, yeah, the DC300, the one that we tested a lot, that one is very wide and very tall, without a wire and without a sponge, and so it really only fit very large faces. Any other questions? We did. The Honeywell mask, we did get it to fit a couple of people. They didn't, not all of them made it into the data set, but I think we fit like 3 people out of the probably more than 100 that we tested. Yes, sir.
Is there some rule about pressure or something on these bits? Like how much pressure does there have to be to form a fit?
They do not have a rule about that. They do expect you in your quality system to explain why you have the pressure that you have, the length that you have, and the material that you're using. But there is not a specific rule about how much pressure should be or need be applied. There's a range of materials you got to think about. Elastomerics are being made out of different plastics. Some of them use silicone, some of them use gel, and then a lot of them are just using like polypropylene folds and cotton. So all of these different materials are being validated by the same team. So it would be hard to make like a pressure rule apply to all of them and it makes sense for all of them.
There were no human adjustments to be made. They just stuck on the head. Like there weren't like things to do to adjust the pressure.
Most N95s do not come with adjustable straps. Most of them do not. Some of them do. A lot more of them do now, especially KN95s that have the external straps, where the strap attachment is not in the breath zone. It's like on the edge of the mask, and it's either glued on or sonically welded. Those ones, a lot of them will have like the pull strap, like you see on the elastomerics. But that's, I see that, or my understanding is that is more of a new trend than, before the pandemic, I've never seen an N95, at least in the hospital or in the OR, where it was adjustable. The elastomerics are adjustable. The PAPRs are adjustable to fit your head, but they don't have straps usually. Yes, sir.
The KN95s
Yep.
and stuff like that.
Yes.
My experience testing them is I've never seen anybody passing one.
Right.
Okay, that was my only question.
that's why we did this project.
They generally have great performing filter media, but they don't fit.
Right. So the idea is that that's why we open source the Fitra. So you can't use the Fitra in a hospital environment because of all of the reasons that Daniel elucidated. But if this is a topic that you care about, you could take the Fitra frame and a KN95, print your Fitra frame, and then attach it.
I will say, though, that with the KN95, with ear loops, I have made a lot of them work by just adjusting the pressure, shortening the straps, or even using very, very small, like even like a rubber band or a plastic loop to add the ability to adjust makes a massive difference. Because they generally have really good filter media. Yes, sir. Yep. When you what?
When I feel comfortable with
Oh.
it, I know it's sealed, and it feels comfortable, and I can wear it. This so many a length of time. I guess you mentioned that there's a time to take it off and replace another one. So I do have 2 or 3 of them that I keep.
Most of the on-label recommendations for N95s for wearing them for extended periods of time is 4 hours, at least in the hospital, and that's really kind of an impossible task. You can't really wear it that long. It literally bruises up your whole face. But the elastomerics have a way better, softer fit. They have a much larger surface area, usually contact, so they can seal under much lower pressure because there's a lot more surface area in contact with the face. And they generally have a material that's like really pliable, like a silicone, like, or a plastic or a rubber. And so those are more comfortable. You can wear them much longer, but they come with cost too. You know, you often can't use them with a lot of different equipment depending on what your workflow is. So let's say you were like an ortho surgeon. It's definitely not going to work for you. You're going to have the inability to look into your instruments. Or if you worked in like a small surgical environment, you definitely can't use a microscope. You can maybe not use a robot. You're not going to be able to use, depending on the interface you're using, you may or may not be able to look into the thing you need to look in because then your face is hitting the device.
All right, well, let's give another round of applause for Daniel.